Hello, Fiveable. My name is Shane. I'll be hosting the AP Stats all year long. Today is all about scatterplots and correlation. Really excited about this unit. As we get deeper and deeper in statistics throughout the year, things become a lot more useful, and we make a lot of connections to things that we did in the past. So I'm going to make a quick plug. I know there's only one person in here right now. Please ask questions throughout this whole process. That's my favorite part about this platform. Rather than making random videos online and just posting them, you can ask me questions and engage in the content with me. So it would really help me, actually, if you'd let me know if you're on this chapter, and if you are, what part are you on, and I can kind of gear this a little bit towards your specific needs. That's the benefit of Fiveable. That's the benefit of these live sessions, is it's here for you. So please ask questions. Going to be with you all year long to help you get a 5 on that AP exam. Yeah, and let's get started. So we're going to start with our first section on chapter 3, which is linear regression. So let's dive into just some overviews. So I'll be going live every Thursday at 8 p.m. Eastern Standard Time or 5 p.m. Pacific Standard Time. The next major topics I'm going to cover: scatterplots, correlation, and least squared regressions line. So that's usually chapter 3 in the textbook. However, some teachers like to go in a different order where they put designing studies, which is why I covered that earlier before this. So that's what we're going to go. You're probably chapter 3 or chapter 4, depending on the book. What we're going to do today, some exam tips, FRQ questions. We're definitely going to use that calculator. This is a big calculator section. It's going to save you a lot of time if you know how to use that calculator. All right, so let's talk about scattered plots and correlation. Here's kind of the agenda for today. We're going to quickly talk about explanatory versus response variables. You probably know a little bit about that already from previous math classes. We're also going to look at scatterplots, which again, you probably know from previous math classes. But what's going to be different is how we describe scatterplots. So maybe you did a little bit of this in Algebra 1, Algebra 2, because of Common Core and the new standards. You might have covered this beforehand, but not all the different requirements for the AP exam. So we're going to focus on the 4 different things, 5 if you count context, that you need to do in order to get the perfect score on one of these questions. After that, we're going to talk about correlation. Again, one of those words you've probably heard before, but stats really requires you to have an exact definition of it. And correlation has a couple things. We talk about direction, form, strength, and unusual. So I should have unusual in there. We'll see that in my later slide. Those are the 4 ways we describe correlation. We're going to talk about R value and the importance of what it gives us. And we'll have some multiple choice and free response questions. So we'll dive straight into explanatory versus response variable. So here's kind of the basic definition of both. The response variable measures an outcome of a study. So you conduct some study, the response variable is usually what you want to determine at the end. An explanatory variable may help explain or influence changes in the response variable. So I have an example right here for time spent studying in hours per week and your GPA. So the response variable here would be your GPA, right? That's the measure, that's what we're trying to the outcome we're trying to measure. Over here, the explanatory variable is going to be the time spent studying. So that will change or affect your GPA. Once again, the response measures the outcome of a study. The study is how much time do you study per week and how will it affect your GPA. The explanatory variable may help explain or influence changes in the response. So your GPA, right? The X, your Y. And that's how I usually help students remember what goes where. The explanatory variable goes on the x-axis. So your response will go on the y-axis. That kind of brings us to the definition of a scatterplot. A scatterplot shows the relationship between two quantitative variables measured on the same individual. So in our last example, each one of those dots is an individual, and it has two quantitative variables associated with that individual. For example, this person right down here studies 10 hours a week. That's one quantitative variable about this person. The other quantitative variable about this person is that they have a 1.0 GPA. Right? So clearly their studying is ineffective. They don't have Fiveable. That is one person or one data point with two quantitative variables attached to it. And scatter plots help us show that and make inferences about it eventually. One variable takes on the horizontal axes while the other takes the vertical. Again, the horizontal is always your explanatory variable, right? The x-axis explanatory. And then your y-axis is always your response variable. All right, so now that we have a scatter plot, how do we describe it? So we describe the direction. We describe anything unusual, kind of like cuss and BS. Form, we want to describe the form. Strength, and then we also want to include context. Remember, context is one of those things you want to put in all your problems, but you only have to touch on it once. You don't have to continue to come back to it. So in each problem, just touch on context once and you should be good. And when I say in each problem, on each part as well. So just in case the problem's broken up into multiple parts, you're probably going to want to cover context for all the parts just in case. The rubrics can be very difficult sometimes. So let's go deeper into each of these topics. So first, oh, and if you notice, this is kind of what I tell kids sometimes. D, direction, U, unusual, F, form, S, strength. So the acronym I use is DUFS, kind of like Duff beer if you ever watched The Simpsons. You guys might be too young for that, but I think it's still on, so you could definitely check that out. Duff beer is the beer that they drink on The Simpsons. So DUFS is the way to remember scatterplot. DUFS with only one F. All right, let's focus on direction. So direction, it's either positive, negative, or, well, yeah, positive, negative, or no correlation. But for now, we're going to focus on positive. And essentially, as one increases, for positive, the other also increases. But for negative, the other decreases. And when I say the other, I'm talking about the other variable. So a positive direction is as one variable increases, so does the other. Negative is as one increases, the other variable decreases. Or we can have no correlation, which we'll talk about in a minute. So let's take a look at an example. Here are two perfect examples. This is positive. As you see, our x or our explanatory variables increasing, right? As these data points get higher, our response variable or our y variable also increases. So it also increases over there. Negative, as x increases, as our explanatory variable increases, our y-axis or our response variable decreases. And we see that right here. So one positive, one negative. Here's an image for no correlation. It's just kind of scattered. There's no real direction. As x increases, y sometimes decreases, y sometimes increases. There's no real pattern here. There's no real direction. So that's direction. There's either a positive, negative, or no direction. And so for right here, this is an example I used for height and weight. We have, as my height increases, we see a general pattern of the weight also increasing. Now, we also have this person right down here, which we'll talk about in a minute. But for right now, we see kind of a positive minus our outlier or our unusual point. And that's what we're going to get to now, unusual. So this point down here is far from the data trend. So any point that strays from the general direction or the general pattern of your points, we would say unusual, and we want to talk about that on our exam, right? So anytime you're answering a free response question and you see a data point far away, like this one down here, you're going to want to talk about it. So this point right here, we might say something like, well, this kid is really, really, really tall, but they're also super, super skinny. So we would expect them to be a lot heavier for their height. And statisticians really like that because that tells us something. That's something super interesting that we want to investigate. Like, why is this person so tall but yet so skinny? And we want to look at that. So we have direction, we have unusual. Next comes form. So for form for this class, this is just kind of a basic college class. As you get deeper and deeper in statistics, you'll see different types of form. But for now, we're just focused on linear or nonlinear. Again, linear and nonlinear should be something you've heard before in your previous classes. If not, now's a great time to ask me what the difference is. But when we have linear, the first is the overall pattern follows a straight line. So if it's linear, we see the overall pattern following a straight line. If it's nonlinear, it doesn't follow a straight line. So it's something different, whether it's quadratic, exponential, whatever. We just know it's non-linear, and a linear model is not the best model for this data set. Here's a good example. Again, our height versus weight is a great example of linear correlation. This one over here clearly doesn't follow this line. There's a clear other pattern. And so we would say this is non-linear. Linear model does not work best for this data. And that's for form again. After form comes strength. So how strongly correlated is the data? So the first thing is strong or weak. You really want to kind of take one of these stances. Sometimes you can use moderate, but strong or weak is going to be your best bet on the AP exam. So data points that do not appear to vary from a linear pattern, we would say that's strong. Versus weak, where data points do vary from the linear pattern. So if they're kind of spread out, if there's a lot of variance or a lot of spread, you say the strength is weak. If the data points are tightly together or the range is small, you would say that the data points are, or the strength is strong. It's a strong correlation. And let me show you some examples of some different correlations. This right here, this first one would be a strong correlation. So we're clearly seeing very little variance or very little spread between data points. Whereas graph 2 shows a weak correlation. There is definitely some spread going on between our points. They're not as compact. They're not as compact. So here's a good example of some strong, weak. Good to go. Okay, so that's how you describe your scatter plots. Now I'm going to show you a couple AP exams, particularly, or a couple AP questions from previous years that have some questions on it right here. This was from 2000, I think it was 2014. It has a scatter plot about the price of sewing machines, and we want to describe the nature of the association between price and quantity. This is essentially asking you to describe the correlation between the two variables. Remember, explanatory, so price is the explanatory variable here, and quality rating is the response variable. So we think that the price may influence our quality rating, right? Like if you buy something more expensive, usually it's probably a better product. usually, not always. And we see that here, actually. So when we're describing this, we would say direction. Well, it looks like it's going in the positive direction. As price increases, so does your quality rating. So that's the direction. We would say positive. Whoops. Next is unusual. Well, we do have something that's kind of unusual. This point out here doesn't follow the general pattern. So something's going on. Well, what is it in this case? In this case, it's a really expensive sewing machine that doesn't have that great of a rating. We would expect, and we'll get into that next session, we would expect this rating to be a lot higher for this price. So it's unusual. After unusual comes the F. Remember, Duff's. The F is form. So it looks like this follows a pretty linear model. You could draw a line and it would get most of the data points. Yeah, so linear model probably is best. We would have to do a residual plot for that, which we'll learn next time. And after that comes strength. This is not very strong. I would say there's probably a weak correlation here between price in dollars, which is the explanatory variable, and quality rating, which is the response variable. So that's one example. Here's another example. This is from 2015. A student measured the heights and arm spans, rounded to the nearest inch, of each person in a random sample of 12 seniors at a high school. A scatter plot of arm span versus height of 12 seniors is shown. Based on the scatter plot, describe the relationship between the arm span and the height of the 12 sample seniors. Now again, we're looking at a question that's asking for just Duff's, right? And don't forget the context. So just Duff's and context. So at some point when you're describing this distribution, you want to talk about the context. So what's going on here? Well, we're talking about seniors in high school, their heights and their arm spans. That's enough to say, okay, this person has context. Now remember, explanatory variable is always on the x-axis. So down here. So does height explain your arm span? So again, arm span is going to be that width right there. If you're a basketball fan, arm span is really, really big. I'm a basketball fan. I'm sure there are other sectors that arm span is important. For me, I know basketball, definitely. So as we can see, again, let's start with our Duff's direction. There's a clear positive direction, right? As one variable increases, so does the other. As height increases, so does our arm span. Got the D in Duff's. U, anything unusual? There's nothing too unusual about this. There's no data points that fall very far away from our trend, right? Our trend kind of goes like this. You can maybe argue this one down here, but it's not very obvious. So after the U in Duff's comes the F in Duff's, which is form. So is linear good or is something nonlinear? And we would say this is not. This is linear. Sorry. So this is a very linear pattern, right? It follows a linear pattern. And last but not least is the S, so the strength. Again, I would say this is not very strong because there is a lot of variance. There is a lot of spread going on between our points. They're not as compact as previous ones. So Duff's, we got all, plus context. Don't forget the context. This is a good one. I believe it was from 2016. And it talked about starting salaries for people in their first year of a job. And it asks you to, does the scatter plot justify the claim made? So the claim was a newspaper in Germany reported that the more semesters needed to complete an academic program at a university, the greater the starting salary in their first year of the job. The report was based on a study used a random sample of 24 people who had recently completed an academic program. Information was collected on the number of semesters each person in the sample needed to complete the program and the starting salary. Again, scatterplots tell us two quantitative data points or two quantitative measures on one person or one subject or one data point. Yep, the data is shown below. So does this support? It does, right? We see a positive direction. We see a positive correlation. There is nothing really that unusual. Maybe this one down here, but again, it's not that far away from the normal trend. Duffs. So F is form. Linear seems to be the best. Seems to be a straight line right there. And strength. So this is definitely pretty weak. We wouldn't say it's very strong. So it does support, but it's pretty weak because the correlation is pretty small, or we would expect the correlation to be pretty small. There was a second part to this question in where they had the type of major then listed. And so now we can actually see a different correlation. So if you look at by major, the direction is actually negative, right? Actually, the more semesters it takes, the less money you earn in each of the three categories. So first is business down here. So again, as the number of semesters only in business, as that went up, your actually starting salary went down. The same was true for physics. The same was true in chemistry. So they kind of flipped this question over. They gave you just the general data points here. And then on the next one, they got a little bit more specific. And they said, hey, here's the major of each of those kids. Now look at the trend. And the direction flipped. It went from positive to negative. And it's also a lot stronger, right? So if we look at business, that's a pretty strong correlation. If I drew a line to kind of model that, we would see a pretty strong correlation. Same with physics, same with chemistry. So interesting how that changed. And again, that was from, I think, from 2016. Here's another question from 2017, where I think 17 or 18, where they asked you to actually, what is meant by these words? So positive, that's direction. Linear, that's form. Strong, that's strength, right? So they actually ask you to describe in words what this means in terms of the context of the problem, which is something they really haven't done before. So it's pretty interesting to see that they kind of took a different spin on this concept. So please make sure that you know the different forms and what they mean. So in this one, they wanted you to say something about as the length in meters of the nose tip to the weight in kilograms increase. Oh, as the meters of length from nose tip to tail increased, so did the weight. Again, one of those questions where they took an old concept and made a brand new question with it. Drew, how's it going? I'm just finishing up covering correlation, scatterplots, explanatory versus response variables. So feel free to chime in with any questions that you have. We're about to get into some AP problems, both free response and multiple choice. So stop me at any moment if you have any questions. All right. So we just covered explanatory. Cool. This is great. It's a great class. You're going to love it. And I know every major, just about every major, is going to need to take it. I have a good friend who is getting her master's in business analytics, and she's literally taking this course. I was looking at her syllabus, and it's exactly the same. But she has to do it in 4 weeks instead of a whole school year. So very, very good that you're going to jumpstart on it. And it's just super fun, super, super relevant. So we talked about explanatory versus response variables. We also talked about scatterplots and how to describe them. Remember, in stats, we have a very specific way of describing scatterplots so that we can make inferences. We talked about correlation. What is correlation? The direction, the form, the strength, and unusual. That's how we describe it. So don't forget, I forgot to add unusual there. It is in the previous slides, but it's not in this one. And now R value. So R value is something brand new where we can actually measure correlation. So we can measure to see how strong something is correlated to another thing. And we're going to dive into that now. So that's usually called the correlation coefficient, also known as the R value. Your calculators are going to tell you that, and this is going to save you a lot of time. So we're going to get into the calculator in a minute. But essentially what the correlation coefficient does is it measures the direction and the strength of the linear relationship between two quantitative variables. So it's giving us two highly important pieces of information. It's giving us the direction. Is it positive? Is it negative? Or is there no direction? It's also giving the strength. So how strong is it correlated? A couple things. So some facts about R. It's only between -1 and 1. You're never going to have an R value other than a number between -1 and 1. So keep that in mind. If you get an R value that's bigger or less than those two numbers, you did something wrong. Next, when R is less than 0, aka a negative number, we have a negative association. So this is where R tells us the direction of the relationship. So if R is between 0 and -1, we have a negative relationship, whereas one variable increases, the other one is decreasing. And kind of the reverse is true. When R is greater than 0, so when R is between 0 and 1, we have a positive association, meaning as one variable increases, so does the other. And to give you an example of that, you can think of our height versus arm span. We would expect as one person increases in their height, their arm spans, right, would also increase. And that's a positive association. Next, an R value that's close to 0 means it's a pretty weak relationship, meaning we don't have a lot of evidence to support that the relationship is very strong. And an R value that's close to either 1 or -1 indicates a strong relationship. And if you have an R value that's 1, that means there's a perfect linear positive relationship. If you have an R value that's -1, it means you have a perfect linear negative relationship. So it really just depends on which way we're at. But the closer we are to -1 or 1, we have a stronger relationship, stronger linear relationship, I should say. All right, so here's some examples of some correlation and R values. The first one you're going to see right here is R is equal to 0. So there's no correlation here. There's no direction. It's really weak. It's all over the place. And you can clearly see. As you move to the right, you're going to see a negative, but it's a weak correlation, right? Our R value is below 0, so we have a negative correlation, meaning it goes as one variable increases, the other one decreases. And it's kind of spread out, right? It's not as compact as some of the other ones we see here. So that means it's a negative relation, or a weak relationship. I'm going to pause real quick for a question. How do you measure R value? We're going to get to that. It's a, let me start answering. So the question was, how do you measure R value? It's a really, really complicated formula that we're going to use our calculator for. Well, I guess it's not too complicated. It just takes a while if you have a lot of data points. So I'll get to that in about like 1 minute. Great question. What type of calculator am I using? I'm using a TI-84 Plus. The TI-83 works as well. The Inspires are pretty common in, I think, the South. I do a lot of trainings in the South. I'm not sure where you're from, Drew, but the Inspires, probably because it's Texas Instrument, so is this, but for some reason, places like Texas or Louisiana, they really like the Inspire. Florida, do you use the Inspire? Did you have one, or are you using one from your teacher? Maybe like a class set. That's right. What math class are you in? Algebra 2, pre-calc. Cool, Algebra 2. Taught that for like 5 years. I love that class. And you're probably doing a little bit of this now if it's Common Core aligned. So you'll actually have a jump start on some other students. Moving right along. Here's an R value that's a little bit closer to +1. And we can see that association there, right? We can see as one variable increases, right, as this bottom one increases, so does our y value. And so we kind of see like a general trend up. But it's not very strong. It's not that close to 1, so we see a little bit of spread. As we move down, we get stronger and stronger. This one is negative, but again, it's still a little bit stronger than our previous ones. And again, stronger meaning the data is a little bit closer together and it follows more of a linear pattern. Up until we get to our very last one, which you could see if you drew a line through that, you would hit a lot of data points, meaning it's a strong linear correlation. Now that negative again means that it's a negative direction. Meaning as one variable increases, the other one decreases. And you're actually probably going to see a little bit of this on your state test. So I believe in Florida, do they use the PARC or maybe the SBAC? But it's the test you take your junior year, and correlation is one of the things that will be on it. So keep an eye out for that. All right, so here's an AP problem that we're going to cover real quick. And just to go back to your question about R value, let me show you the formula for it, how to calculate it, so you can see how complicated it really is. Just pull it up real quick. All right, let's minimize this. Let's put up the formula. So take a look here. Let's see if I can zoom in. There it is. Oh, too much. All right, so here's the formula for R value. Again, our calculators do this, so you don't need to memorize it by any means. But you take your data point, the X value. So remember, in Scatterplots, we have 2 quantitative variables for one person, or one data point. So you take your X value, subtract it from the average of the X values, then divide it by the standard deviation of the X values. You then multiply that by the same thing for your Y values. And you add them all up. Again, super complicated. You'll never have to do this by hand. We have technology for that. There's no point in wasting our time doing it by hand when we have something that does it faster. But sometimes it's good to look at the formula to see where it was derived from. So let's go to our AP problem from 2002. And let's take a look. We'll learn how to use our calculators. And in Algebra 2, you're probably going to have to learn to use your calculator to make scatter plots as well to save you a little bit of time. So it says animal waste lagoons and spray fields near aquatic environments may significantly degrade water quality and endanger health. The National Atmospheric Deposition Program has monitored the atmospheric ammonia at the swine farms since 1978. The data on the swine population size in thousands and atmospheric ammonia in parts per million for one decade are given below. Construct a scatter plot. So here we want to figure out, okay, what is our explanatory and response variable? So we want to know what explains the other. So do you think the population explains how much atmosphere or how much ammonia is in the atmosphere, or the other way around? And so for us, it's going to be, this is the explanatory variable, which is our X, explanatory. And this is going to be our Y, or our response variable. So I'm going to write response. And over here, I'm going to write explanatory. So calculator time. So this is where you want to use your graphing calculator. It's going to save you a whole bunch of time. Let's scoop this up so you can see what I'm doing. Going to turn it on, clear anything that's there. Let's go ahead and zoom out a little bit. All right. So to enter data into your calculator, again, I covered this in the earlier units, so I'm going to go a little bit fast, but you're going to hit the button that says Stat. Then you're going to go to Edit. So hit Enter, which is down here. And then you'll have a bunch of lists. So these lists are where you enter in data, quantitative data. Can't enter categorical, quantitative. So I have stuff already in my list. So I want to go to the very top and hit the button that says clear. Once I hit clear, I then hit enter, and it should clear my list. Now, because scatterplots require 2 quantitative data sets, I also need to clear this one. And again, I went to the top, hit the button clear, then hit enter. Now, this is very important for scatterplots. Because each data point is associated with an X and a Y, you have to enter your data in order. You can't just go all over the place, because then this X might be associated with this Y, and that's not the case. So I take my time. I don't like to rush it. I do 0.38, enter, 0.50, enter, and I keep going until I have all the data points in there. And Drew, this is a good time if you know some seniors who might be graduating that can sell you one of these calculators. Great idea to talk to them at the end of the year. Maybe put in a little plug right now for it, because these are kind of expensive. They can be around $100. And I recommend the TI-84 versus the TI-83, because when we get towards the end of the year, the TI-84 does some tests that the TI-83 cannot do, or they can, it's just a little bit more difficult. Boom, perfect. All right, I had the same situation. I had an older sister, older brother, and we just passed that calculator down. Now let's do the Y. So 0.13, again, notice 0.38 and 0.13, they're the same. So I have to keep them on the same line. 0.21, 0.29, 0.22. Okay, so to make a scatter plot, you're going to hit the second button, and then you're going to hit stat plot right here. This is where you make any sort of plot, whether it's a box plot, scatter plot, cumulative relative frequency graph, anything comes here. So you're going to hit enter into the first plot. You're going to want to turn it on, so we're going to hit the enter button. The type of graph that we want is a scatter plot. This is a histogram. This is a box plot. We want a scatter plot. Our X, remember, our explanatory variable was swine population, and we put that in L1. Atmospheric ammonia was in Y, so that's our L2. And then the mark is just like, what do you want to see when you're actually looking at the data points? Doesn't really matter. I like this one, just personal preference. After that, we want to tell our calculator to zoom in on the statistics that we entered. So we hit the button zoom, and we go down all the way to number 9 that says stat. Right there. Boom. And then there we see it. So for this class, or for this year, they wanted you to graph it. They really don't have you do that anymore, but graphing it by calculator is just a whole lot easier. So we could see right away, right? There is a positive direction, right? There's really nothing unusual. The form is linear. We could draw a line, and that would probably be the best model for it. And the strength is relatively strong, but we'll find out exactly how strong when we calculate R using this calculator. So to calculate R, we're going to quit out of this. So second, quit. You're going to go down here to stat. Go over to calculate, and then press the down button until you get to, I think it's number 9. Oh, number 8, line reg A plus BX. Now, if you notice, this looks very familiar to your old, and probably algebra 2, you know this well, the linear equation y equals mx plus b. But in stats, we use y equals a plus bx. So essentially, we're just kind of switching these around where, grab a new color, the slope has moved here, and the y-intercept has moved here. A lot of times people ask why, not really sure. That's just how statisticians do it. Yeah. So we hit enter. And now we want to tell the calculator, okay, what type of line do you want to run with what type of data? So we're going to hit second. Let me get back here. Because we put our data in L1 and L2. So we want to hit second and then the 1 button. You see how the L1's in blue? That means we're going to get L1, comma, second, the 2 button, because that has L2 above it. Then we hit enter. And there's what we're going to get. We're going to dive deeper into the actual line of best fit in next week's session. But for now, it's just good to get that R value. Now look at that R value. We have an R value of 0.85. So that tells us a couple things. One, that it's strongly correlated, right? An R value closer to 1 means that it's strong. The relationship is strong. And then we also notice that R is greater than 0. When R is greater than 0, that means we have a positive relationship. All right? Any questions before I move on? Again, we'll get to all the specific stuff next week when we get to talk about line of best fits and predictions. Like, what would we predict if the swine population was 3? What would the atmospheric pressure be? And this is where stats become super, super powerful, right? Like if you're owning a business and you notice, hey, the more Adidas shoes I stock, the more money I make. What would happen if I stocked this many Adidas? How much money would I expect to make? Really stuff that's really going to affect whatever you do in life. I work for a public school in Oakland, and a lot of the times I wish that they would use statistics to make decisions, especially when it comes to budgets. Because a lot of the times they're like, hey, we're going to throw hella money at this new program, and then they don't follow up to see if it worked or not, right? They don't run the data to see if it worked. And there's really not much you can do with that if you don't see the data. Now let's go into a couple multiple choice problems, and then we'll get you out of here. So here's our first multiple choice problem about explanatory versus response variables. So, other things being equal, larger automobile engines consume more fuel. You're planning on an experiment to study the effect of this engine size in liters on gas mileage in miles per gallon of sports utility vehicles. In this study, blank. A, gas mileage is the response variable, and you expect to find a negative association. So let's break that down. So the response variable, again, is what we're trying to measure. And we are trying to measure gas mileage. We're trying to see how much gas mileage based on your engine size. Would we expect a negative correlation? So would we expect, as your engine size increases, would we expect your gas mileage to go down? And the answer is yeah. If you have a heavier car, heavier cars mean less gas mileage. My first car, probably when I was your age, Drew, was a 1981 Caballero. And I got about 7 miles to the gallon. And it was really heavy. It was really big because it was made back in the day. Now I drive a Honda Fit, which is a really tiny car with a small engine. And I get about 28 miles to the gallon. So A is going to be our right answer. But let's look at some other ones just in case. Gas mileage is the response variable, so that's right. And you would expect to find a positive. We wouldn't. We wouldn't expect a heavier engine to produce higher gas mileage. That wouldn't work. C, gas mileage is the explanatory variable. Nope, wrong right away. Gas mileage is the, nope, wrong right away. Gas mileage is the explanatory, nope, wrong right away. So we can eliminate a couple choices real quick. Let's try next one. And on the AP exam, so I did SAT, ACT prep for about 6 years before I became a full-time teacher. And I told my students to physically cross out any answers that they knew were wrong, because I didn't want them coming back to that question and maybe thinking that was a possibility. So on the AP exam, or really any exam that you take, if you know an answer is wrong, physically cross it out. There's something that it does with the mind that makes it that makes you not go back to it. So let's look at our last multiple choice problem. the correlation between the heights of fathers and the heights of their fully grown sons is 0.52. The value was based on both variables being measured in inches. If fathers' heights were measured in feet, 1 foot equals 12 inches, and son's height were measured in furlongs, 1 furlong equals 7,920 inches. The correlation of the father's and son's heights would be, all right, so this is saying, hey, if we had a scatter plot in inches of the son height and the father height, what if I then changed it to be still the father's height, still the son's height, but in this, it was feet, and here it was furlongs. So this is getting to the main thing about correlation, or one of the things about correlation, where it doesn't matter if you change the units, the correlation is going to stay the same. So we would still have the same correlation. Doesn't matter on the unit. So our correlation is still going to be 0.5, which is positive, which is linear. There's nothing really unusual that we can see. And the strength is moderate, I would say, maybe a little weak, because it's not that close to 1. Thank you for your time. I was in a training this weekend for AP Statistics in San Diego, and I got to connect with a lot of good AP Stat teachers. I'm going to send out this resource to them so they can share with their students. So I expect to see a lot more kids in here in the next upcoming weeks. And as the year goes on, students tend to think, oh, shoot, the AP exam's coming close. I got to make sure I'm studying for it. And honestly, this is such a good resource for you. You get to ask me questions. We get to interact. You can go back and watch the videos. So Drew, you can go back and watch the videos at the start of next year. I'll be here next year, so I can also walk you through them again. But just an invaluable resource that if you paid a private tutor would be a whole bunch of money. I used to do that as well. And people would pay me like $60 to $70 an hour to sit down and do work with their child. This is a much more efficient way. I get to sit in my classroom and help students with stats, which is a subject I love. And eventually every person is going to have to take it, especially if they're in college. Well, I guess only if they're in college. But your major is going to be, it's going to require it, right? And just making good decisions. And obviously, when electing people to represent you, you want to make sure that the data that they're giving you is accurate and you can decipher it. Awesome. I'll stick around if you have any specific questions. But in the meantime, check out Fiveable. If you have friends or sisters or brothers who are taking AP Stat, send them this way. Even if they're taking regular statistics, send them this way. All this stuff is covered in regular statistics. In AP Stat, we just cover it a little bit quicker. So spread the word. Get more people involved in this. Let's take the AP classes by storm. And I'll see you guys next week, Thursday at 5 o'clock Pacific Standard. Or Drew, for you, I believe that's 8 o'clock Eastern Standard Time. Thank you, and I'll stick around if you have any questions. Awesome. How was it? So I'm hoping for some feedback. All right. Have a good one. We'll see you next week. And yeah, if you have any questions about Algebra 2, I can also answer those real quick. If you